Building off what we just looked at, to find the nth term of an arithmetic sequence. The nth term of an arithmetic sequence has the form a sub n equals a sub 1, and remember that's our first term here, plus n minus 1 times d. Now the n would just be like the place in line. So if we're finding the 50th term, we plug in n equals 50. So d is the common difference between consecutive terms, and a sub 1 is our first term. So we're asked to find the formula for the nth term of an arithmetic sequence whose common difference is 3. Let's just write that down. D equals 3, and whose first term is 2. So we got a sub 1 equals 2. Filling that in, we're going to have a sub n equals first term 2 plus our n minus 1 times our common difference of 3. And that is a perfectly acceptable form. Now, personally, I flip it around just a little bit, and I would make it 2 plus 3 times n minus 1. That's kind of my go-to setup. But also, if you were to distribute that 3 to both of those, you distribute the 3 to the n and the negative 1, you'd end up with 2 plus 3n minus 3, which if you clean that all up, you could also end up with 3n minus 1. That's another acceptable version. Now, all these mean the same thing. Now, what we just found above is called an explicit formula. In other words, explicit meaning you can go directly to the nth term. You don't need to know any previous terms before that. So I could plug in 50 and find the 50th term. I can plug in a million and find the millionth term. Not too difficult, even with a million. Now, similarly, if you know the nth term of an arithmetic sequence and you know the common difference of the sequence, you can find the n plus first term using this thing called a recursive formula. So we're going to say a sub n plus 1. In this case, this would be like our next term. I missed a letter there. Next term. So to find our next term, what we can do is take the term that we currently have and add our common difference to it. Now, when we've done this in the past, we did this a little bit yesterday, or on the previous section. We did a sub n equals a sub n minus 1 plus d. These really mean the same thing. So like a sub n plus 1 is the next term after the one we currently have. And a sub n minus 1 would be like your previous term. This really means the same thing. So to find my next term, I have to take my current term and add the common difference. Or to find the term I want, I have to take the previous term and add the common difference. It's the same thing. Now, we can also find the sum of a finite infinite, or sum of a finite, or arithmetic, there we go, sequence. So the sum of a finite arithmetic sequence with n terms is found as follows. S sub n, so the sum of the first n terms, is equal to n divided by 2 times a sub 1 plus a sub n. Now, another way that I've seen this, another way that I've used this, is I say n times a sub 1 plus a sub n over 2. Now, I kind of like that way better because it's like n, the number of terms you're adding up, times, really it's the average of your first and last terms. I kind of like that approach. It's the same thing either way. I'm probably going to use the one on the right more often, but again, doesn't make a difference. So the sum of the first n terms of an infinite sequence is called the nth partial sum. So in most cases, infinite arithmetic sequences aren't going to have like a finite answer. So the nth partial sum can be found by using the formula for the sum of a finite arithmetic sequence. So we're asked to find the sum of 1 plus 2 plus 3, 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. We could just go through and add them all up. Or we can look at, it's like we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. So we're really finding the 10th partial sum. And in this case, if n is 10, really the only other things we need to know are a sub 1, so our first term in this case is 1, and the nth term, in this case the 10th term, which in this case happens to be 19. So plugging that in, I'll use the first version, 10 over 2, so the n over 2 times 1 plus 19, your first and your last terms. Well, 10 over 2 is 5, 1 plus 19 is 20, so this is 5 times 20, so that means the 10th partial sum is 100. So if you were to add this list up and just add them up as is, it's 100. Now again, I often use the other formula, so it'd be S sub n equals 10 times 1 plus 19 divided by 2. Again, it's the same thing, just in a different organization. We got 10 times 20 divided by 2, which is 10 times 10, which is, hey, look at that, that's also 100. It does not make a difference in which order you do it. You get the same answer either way. So whichever version of the formula works best for you is going to be the best version. Now, similar to that, this one's a little more challenging. We're not adding just 10 terms, we're adding, well, technically 51 terms. So we're saying from n equals 0 to 50. So starting with the 0th term and going up to the 50th term, and this is how we find each term. So our first term, we got to figure that out. In this case, we're not dealing with a sub 1. We're going to start with the lowest term of a sub 0. And we're just going to plug that in. We got 50 minus 2 times 0. Well, that just cleans up nicely to be 50. Now, our last term is going to be the 50th term. And it's going to be 50 minus 2 times 50, which is going to give us, well, 50 minus 100, which gives us negative 50. So the sum in this case, S sub n equals n over 2 times a sub 1 plus a sub n, again, your first and last terms. In this case, we're dealing with 51 terms. Remember, if you include 0, that's adding another term. So like 1 through 50 would be just 50 terms, but 0 makes it 51 terms. So we got 51 over 2 times 50 plus negative 50. So we end up with 51 over 2, times 0. Well, 51 over 2, it's not the nicest thing. It's like, 25.5, but times 0 is just 0. So the sum of the first 51 terms of the sequence, if you were to find them all, you'd end up with like 50 and 50, 46, 42. Add those all up. You keep going all the way down to negative 50. You end up just getting 0. So I'm glad we didn't waste our time finding all 51 terms and adding them up. Example 7. In a golf tournament, the 16 golfers with the lowest scores, remember low scores in golf means good things, win cash prizes. First place receives $100, second place receives $95, third place receives $900, and sorry, did I say $95 for second place? $950 for second place. Third place receives $900, and so on and so forth. So starting off this pattern, we're asked to figure out what the total amount of prize money that the award is. We got $1,000 for first place, $950 for second place, $900 for third place. We could just go through and find them all. Or we can use a formula. We got D equals, well, it's going down by 50 every time. Now, if we're using the formula for the sum of the first 16 terms, we're going to say N equals 16. We're adding up 16 players like total cash. Our first term, we already know, is 1,000. Now, our 16th term, the last term, we don't know that yet. But we do have the formula. Remember, A sub n equals A sub 1, your first term, plus n minus 1 times your common difference of D. We know all those. We know A sub n. We're replacing that with A sub 16 because n is 16. Our first term is 1,000 plus n, in this case 16, minus 1 times our common difference of negative 50. So we got 1,000 plus 15 times negative 50. Cleaning that up a little bit, that's 1,000 plus 15 times negative 50. You can check that on the calculator. That's negative 750, so it's plus negative 750. And when we subtract those two, we end up with $250. In other words, the 16th place golfer is going to get $250. Not bad. Now, using the formula, S sub n equals n over 2 times our first term plus our last term. We're now looking for S sub 16 because we're adding up the first 16 terms. So we got 16 over 2 times 1,000 plus our final amount of 250. 16 over 2, that's 8. 1,000 plus 250 is 1,250. When we add those together, we get 10,000. So all together, the 16 golfers get $10,000 in total. So this, even though like each individual golfer is only getting $1,000 or less, the organizers of this tournament have to give out $10,000 total dollars.